Hi everyone, welcome to my channel VIDYANIRMAN, which is helpful for CBSE, ICSE and state students.
Problem. If the resistance of your body is 1 lakh ohm, what would be the current that flows in your body when you touch the terminals of 12 volts battery? I am repeating the problem. If the resistance of your body is 1 lakh ohm, what would be the current that flows in your body when you touch the terminals of 12 volts battery?
In the problem, given that the resistance of the body is capital R is equals to 1 lakh ohms. So, battery potential difference is V is equals to 12 volts. We need to calculate the amount of current that flows through our body. So, the electric current capital I is equals to question mark.
So, to calculate the electric current, we need to go with the Ohm's law. We know Ohm's law is V is equals to I into R. From this, I, capital I is equals to V by R. So, we know the V value as 12 and resistance value 1 lakh. See, you keep in remember that for 1 lakh we have totally 5 zeros. So we can write this as 12 into 10 power minus 5. So because 12 divided by here totally 5 zeros, so we can write this as 10 power 5. So this value when it comes to numerator it becomes as a 10 power minus 5. Final answer is 12 into 10 power minus 5. What is this? This is the electric current. So unit of electric current is amperes. And also by adjusting the decimals we can write the answer as 0.5. So we need to have five places. Okay, triple zero, the last two places will be 1 2. So the final answer is 0.00012 amperes. This is the amount of current when we touch a 12 volts battery that flows through our body if we have a resistance of 1 lakh ohms. This is the amount of current. Okay, thank you.
So the next problem, a uniform wire of resistance 100 ohms is melted and recast with a wire of length doubles that of the original. So what would be the resistance of the new wire formed? I am repeating the problem. A uniform wire of resistance 100 ohms is melted. That melted wire is recasted into a wire of length doubles that of the original. What would be the resistance of the wire? So initially wire is having some length and resistance, and the length is changed, then what will be the new resistance? So by reading the problem we need to write the following values. So the change is recasting. So before recasting, the initial length of the wire is L1, and also that wire is having some resistance. That initial resistance is capital R1 is equals to 100 ohms. The change is recasting. So after recasting, the wire length changes. Like it becomes doubles to that of the original length. So the final length L2 is equals to, it is 2L1 double to that of the original. And also the resistance also changes. So final resistance R2 is equals to, we need to calculate. We know that for a conductor, the resistance is directly proportional to the length of the wire. So R1 is proportional to L1 and R2 is proportional to L2. Now equations 1 and 2, R1 by R2 is equals to L1 by L2. We have to calculate the final resistance R2. So by using this formula, by doing the cross multiplication, as R1 by R2 equals to L1 by L2. After cross multiplication, R2 is equals to R1 into L2 by L1. We know the value of R1, L1, L2. By substituting all these three values in this equation, we will get R2. So R2 is equals to R1 means R1 into L2 value is 2L1 by L1. L1 gets cancelled. So it is 2 into R1. We know R1 value is 100 ohms. So it is 2 into 100 ohms. Finally, the resistance R2 is equals to 200 ohms. Next problem. A house has 3 tube lights, 2 fans and 1 TV. Each tube light draws 40 watts. The fan draws 80 watts and the television draws 60 watts. So on average, all the lights are kept on 4 hours, 2 fans for 12 hours and the television for 5 hours per a day. Find the cost of electrical energy used in a 30 days at the rate of rupees 3 as per kilowatt hour. Students, here I prepared a table that provides the information in the given problem. Device rated power time utilized. Tube light is 40 watts 5 hours. Fan is 80 watts 12 hours and TV is 60 watts operated for 5 hours. So first step, we calculate the power consumed by a tube light in a day, and in the second step we calculate the power consumed by a fan, and in third step we calculate the power consumed by a TV. So in this step 1, power consumed by a tube light in a day is equals to 40 into 3 into 5 hours. Here 3 is the number of tube lights as per the problem. Number of tube lights is 3. So 40 into 15 watt hours. So we know that that is 600 watt hours. We convert this into kilowatts. So to do that, we multiply and divide 600 with 1000. So 600 into 1000 by 1000. Zeros gets cancelled. It becomes 0.6 into 1000 watt hours. We already know that 1000 watts is equals to 1 kilowatt. It is very important. So it becomes 0.6 kilowatt hours. That is written there. So it becomes 0.6 kilowatt hours. This is the power consumed by 3 tube lights in a day. Step 2, power consumed by 2 fans in a day. So that is 80 into 2 into 12 hours. So it becomes 1920 watt hours. To convert into kilowatt hours, we do 1000 by 1000. 192 into 1000 by 100 is equals to 1.92 into 1000 watt hours. It becomes simply 1.92 kilowatt hours. It is equation number 2. Step 3, power consumed by a television in one day is equals to 60 into 1 into 5 hours. So it becomes 300 watt hours. So to convert into kilowatt hours, we multiply that with 1000 by 1000. Finally it becomes 0.3 thousand watt hours. So it is 0.3 kilowatt hours. This is equation number 3. So by adding equations 1 and 2 and 3, we get the total power consumed by all the 3 devices in a day. That is, here we noted here 0.6 kilowatt hour and 1.92 kilowatt hour and 0.3 kilowatt hours. By adding all these 3, we get the final power consumed in a day, that is 2.82 kilowatt hours. This is the total power consumed by all the devices. in one day. So the total power consumed in 1 month, that means 30 days, is equals to 2.82 into 30. So its value become 84.6 kilowatt hours. 84.6 kilowatt hours is the total power consumed by all the devices in 30 days. So we need to calculate the total cost. Rate of cost per 1 kilowatt hour is equals to 3 rupees. So rate of 84.6 kilowatt hours is equal to 84.6 into 3. So its value is 253.8 rupees. So the total cost for the all devices used in 1 month, its value is equals to 253.8 rupees.